So if you look at your handout, we've pretty much covered all the stuff on our handout in various sections except these two cases right here. And that's going to be the subject of section 6.5. The sum of cubes formula and the difference of cubes formula. So let's work on those. And let me start by showing you some patterns and some tricks in keeping these formulas straight. So for starters, we've got a cubed minus b cubed and a cubed plus b cubed. Each of these have formulas. And let me write down the formulas minus the signs. That is, I'm not going to put in the signs just yet. And what I want you to see in working with these formulas is that there's a similarity between the formulas, at least to a point. So there's the formulas before I put in the signs. And let me discuss the signs here. Now up to this point, these formulas are identical. Difference of cubes and the sum of cubes are both the same. But then we start putting in the signs. And the signs follow this pattern. These two signs are always the same. So I'd make that a minus. What do you think an O here would stand for? Opposite. And the last one is always positive. So same sign, opposite sign, always positive. Now that holds true whether or not you're working with this formula or this one. Same, opposite, always positive. So take a second for yourself and plug in the signs here. What would they be? So what would the signs be in this one? Austin? Good. Positive? Good. Positive, negative, positive. Now, one thing that helps me out when I work with these formulas, it catches a lot of mistakes, is one negative sign per customer. So here's the negative sign, here's the negative sign. But both of these have exactly one negative sign. If you accidentally write down 2 or none, then you know there's a mistake. Go back and fix it. The idea when you're factoring these things is you're going to have a binomial times a trinomial. Always. If you try and factor something like this in other ways, it's just not going to work. We'll start with problem number 26. Eight u squared, or excuse me, 8u cubed plus w cubed. When you're faced with these kinds of things, in fact, when you have to look at any factorization, you should always look for the GCF. Well, there isn't one here, so move on to something else. After you look for the GCF, count the number of terms. There's only 2 terms in what you're trying to factor. That doesn't leave us a whole lot of choices. If there's 2 terms, then it's either the difference of squares, the sum of squares, the sum of cubes, or the difference of cubes. It has to be one of these 3. In fact, because we've got numbers that are cubes, we can eliminate these right away. And finally, it's the sum of 2 things that are cubed. So let's see if we can't work with it from here. Figure out the first binomial. What do you cube to get 8? You can look at the left-hand side board. It's got a list of your first 10 perfect cubes given to you by the same athletic, charming, handsome, and modest person that gave you the first 20 perfect squares. So what do we cube to get 8? 2. So this would be a 2 and a u. What would you cube to get this term? More than just a 1. W, yeah. W. So 2u and a W. Let's use both of these. I'm going to use these two terms to generate these three terms. Don't worry about the signs just yet. We'll go back afterwards and fill in the signs the same way we did with this stuff here. To start with, we'll do 2u times 2u. We're going to take this term and multiply it by itself. What's 2u times 2u? 4u squared. That worked out pretty good. Let me do it again with this term. W times W is a W squared. I need one more term. I know it's going to be a binomial times a trinomial. 2 of them times 3 of them. What else can I do to get another term? I've multiplied this by itself. I've multiplied this by itself. Is there something else I can do? Yeah, multiply them together. 2u times W. 2uw. Great. So I need to fill in some signs now. Madison, some help please. What would these be? Good? Positive. Positive, negative, positive. Great. And that's it. This is your answer right here. That's how this factors. Comments on this or thoughts, questions? Is there something about this that maybe I went over a little too fast? Let's see that it actually works. Let's take 2u plus w. How could I prove that it actually works? Yeah, multiply it out. So if I distribute here, 2u times 4u squared gives me 8u cubed. The middle terms give me minus 4u squared w, and the outside terms give me plus 2uw squared. Now let's distribute the w. I get 4u squared w minus 2uw squared plus w cubed. What happens when I add these together? Those cancel and these cancel. So I'm left with 8u cubed plus w cubed. And that's it. It checks. That's exactly what we started out with. So it proves that our factorization was correct. Let's do some more here. Let's try problem number 36. 27, a to the third minus b cubed. Again, kind of the same thing that we were facing with the last one. There's no greatest common factor. You're trying to factor something that has two terms. So it's not the sum of cubes or sum of squares. So you start looking at other things, like the difference of squares or the difference of cubes. And pretty soon you figure out that, okay, that's going to be the difference of cubes. I've got cubes in the exponents. Elizabeth, what do I cube to get the first term? 3 what? 3a. How about the second term? What do I cube to get that? A b. So start out by figuring what do you cube to get each of those first two terms. And then use these two terms to come up with these three terms. Now, do you want me to do this one, or do you want to give it a try? All right, let's give it a try. I appreciate the spirit on that one. Good job. So go ahead. Give it a try. All right, I'm impressed. Many of you are doing real well on this. So, the first term, 3a times 3a gives me a 9a squared. The second term, b times b, gives me a b squared. And when I take the product of these two, 3a times b, I get 3ab. So, real quickly, we get our product. The only thing left then is to figure out the signs. Same sign, opposite sign, always positive, minus, plus, and plus. One negative sign per customer. Cool. Let's make these, let's do maybe two more. Problem number, well, you know what? I'm going to kind of modify this one so it's not exactly from the book. So let's do 64a cubed plus 27b cubed. See if you can't do this one completely on your own. LeBaron, what do I cube to get the first term, please? Not quite. We're looking for something we can cube, and actually, I'm glad we had a little hiccup on that because it reminds me to show you if you're not around that list. In fact, years ago, people used to copy that list down just to have it in their notes. Nowadays, people walk over there with their cell phone, take a picture. All right. Either way, it's nice to have around the first 10 perfect cubes. I'm not going to give you anything bigger than that. But if you're looking at something going, I just don't know these things, what could you cube to get that? One way to answer that question is with the cube root. So to remind you, to find the cube root, at least on the graphing calculator, you do the math key, and then the fourth option down allows you to do the cube root. 64 is kind of special because it's 8 squared, but it's also 4 cubed. So it's kind of both. So it's going to be a 4 here. So 4a. What else? Plus 3b. So 4a times 4a gives me 16a squared. And then 3b times 3b gives me 9b squared. And finally, 4a times 3b, 4 times 3 is 12ab. Plus, same sign, opposite sign, always positive. Yay. Now, sometimes in working with these things, in addition to factoring this as, say, the sum or difference of cubes, you're going to have to factor out a GCF. So our last example here would be problem number 46. No, not 4. Is it 46? Yeah, 46. X to the fifth minus 125 x squared. So, if you guys will help me out on this one, we can be done with this section after this problem. What should I do here first? Take out the x squared. Thank you. So x squared times x cubed minus 125. Now the x squared is going to stay out in front. But what's left inside here is the difference of cubes. So let's see if we can't split that up like that. What would I put in the first binomial here? Preston? All right, an x, that's a good start. You can look at the list, or you can take out your calculator. And then 5, good. X and a 5. X times x is x squared. 5 times 5 is 25. X times 5, I'll write it as 5 times x. Nice. Nicole? No, Natalie. Yes. How about the signs here? What signs go in here? Mm-hmm. Good. Good. Same sign, opposite sign, always positive. All right. Well done. For homework. Let's see which ones I want you to do here. Try 17 through 29. 37, 41, and 43. Now there's some review problems as well. So the review problems, if you wanted to do some problems that are review in nature, would be 49 through 53, 65, and 67. It's kind of up to you how much you want to do on the review, but I suggest at least you do this much to get some practice for section 6.5. Good luck.